Good morning. Today we will study about term symbols. What are term symbols? What are the different types of coupling? What are the different types of coupling? RS coupling, JJ coupling. How to derive the term symbols, spectroscopic states for P2 configuration. It is a very common question asked in your semester as well as in competitive examination. Derive the term symbols for P2 configuration. P2 configuration. You will see. And we have in the previous class we have studied the different possible electronic arrangement for P2 configuration. So there are 15 possible electronic arrangements called number of microstates. We have seen the formula to calculate the number of microstates, how it is calculated for big state D4, D3, D4. It is not possible to write completely. So you can use the formula. You see the previous video. I have given the formula to calculate the number of microstates. It is also one of the common question asked in competitive examination. Now we will see what are term symbols. Term symbols are nothing but short representation of electronic configuration of an atom. Short representation. For example, 1s2, 2s2, for carbon 1s2, 2s2, 2p2, it is long. Instead of that, it is the shortest representation of electronic configuration and the resultant angular momentum of an atom. Okay, now it is expressed in the form of this L superscript 2s plus 1 and capital J. Okay, what is 2s plus 1? It is nothing but spin multiplicity. We have studied earlier. Spin multiplicity selection rule. Spin multiplicity. Okay. Next L. L. What is L? L is the S. What is S here? S is the resultant spin quantum number. Resultant. For example, if you take a multi-electron atom, okay, you take multi-electron atom, there are several electrons in it, and each electron will have, or each electron move in an orbital, as well as it will spin about its own axis. Therefore, it will have both orbital angular momentum as well as spin angular momentum. Okay, so the resultant for each the resultant spin quantum number, you will add the spin quantum number of different various electrons present in the atom. Similarly, L equal to the resultant spin quantum number. Okay, resultant spin quantum number. These two, again, next J equal to total angular momentum quantum number. J equal to, actually J can be determined, the value of J can be determined by two methods. Remember, the value of J is very important, can be determined by two methods. One is called RS coupling, Russell Saunders coupling, or LS coupling. Another one is JJ coupling. JJ coupling. RS coupling, LS coupling is applicable for elements with Z equal to 30 or less than 30. For lighter elements, it is applicable for lighter elements. Okay, it is applicable for lighter elements with elements with the atomic number up to 30. For heavier elements, JJ coupling is used with atomic number greater than 30. Okay. In this, for example, in the case of heavier element, the spin orbit coupling is strong. Spin, for example, you have spin angular momentum and orbital angular momentum. Okay, spin angular momentum and orbital angular momentum. They will couple together. They will couple very strongly. Okay. Here the spin orbit coupling is very weak. Here it is very strong. Remember. And for how J value is obtained? For multi-electron atom, the J value is obtained. The capital J value is obtained from capital L plus capital S. What is capital L? L equal to the resultant angular momentum of an atom is obtained from the sum of the individual orbital angular momentum of each electron. For example, you have electron 1, it will have electron 1 will have the orbital angular momentum L1. It will couple with the orbital angular momentum of the second electron, and again it will couple with the orbital angular momentum of the third electron, etc. Since we are for multi-electron atom, there are several electrons. Therefore, summation of Ml. Similarly, spin angular momentum for electron 1, spin angular momentum is S1, and for electron 2, the spin angular momentum, they will couple. It will give the resultant spin angular momentum. Okay, they will couple independently to give the resultant spin angular momentum summation of Ms. Therefore, J equal to L plus S. Okay, this is the orbital angular, this is a vector quantity. So that is vector. Therefore, J can have values modulus of L plus S to modulus of L minus S. For example, J equal to 1 means plus 1, 0, minus 1. Okay, three values. Okay, now for L equal to for capital L, for small l we call L equal to 0 means small s. L equal to small l equal to 1 equal to small l, we say small p. L equal to 2 means small d, etc. For capital L 0 means S state, 1 means L equal to 1 means P state, it represents. L equal to 2 represents D state, L equal to 3 represents F state, L equal to 4 represents G state, L equal to 5 represents H state, etc. Okay. So, in the case of JJ coupling, see, in the case of JJ coupling, the orbital angular momentum of the spin orbit coupling is large. Therefore, the spin angular momentum of electron 1 couples with itself. Here, it won't couple. See, it won't couple. It will couple with the orbital angular momentum of one electron with another electron because it is strong, it is weak. Here, the spin angular momentum of electron 1 coupled with and similarly J1, small J1, J2 equal to for second electron, for third electron. Therefore, the total angular momentum quantum number is equal to J1 plus J2 plus J3, etc. Okay. Now, let us apply this for obtaining the term symbols for P2 configuration. What are the ground state, excited state term symbols for P2, terms for P2, spectroscopic state for P2 configuration? Okay. First, as I said earlier, there are 15 possible electron 2 up. We can arrange the electron in different ways. Okay. So, by following the Pauli exclusion principle, by obeying the Pauli exclusion principle, there are 15 possible arrangements. Now, this is Ml. Okay, Ml equal to plus 1, 0, minus 1. You have studied earlier. Okay. Now, if you look at summation of Ml equal to Ml, small Ml equal to capital Ml. Therefore, summation plus 1, 0. Therefore, plus 1. Next, this one is 0, minus 1, therefore minus 1. So, I am summing up. Okay. Similarly, Ms, summation of Ms, plus 1 by 2, 1. Okay. So, for example, here, if you look at here, minus 1, therefore, Ml, capital Ml equal to minus 2. Okay. Minus 1, minus 1. 2 electrons. Therefore, minus 2. Here, minus of, plus of 0. So, we have obtained the Ml, Ms values. Now, to obtain the terms for P2 electronic configuration, there are 3 simple rules. Okay. So, what are the simple rules? Choose the maximum Ms value and its associated Ml. Choose the Ms value is maximum is plus 1. Okay. The maximum value is S equal to 1. S equal to 1, that is S equal to summation of Ms. Therefore, S equal to 1 and Ms equal to plus, therefore, L equal to 1. L equal to again Ml equal to summation of Ml equal to L. L equal to 1. Therefore, Ms, what are the possible Ms values for S equal to 1? Ms equal to plus 1, 0, minus 1. For L equal to 1, for example, we have seen L equal to 1, plus Ml equal to plus 1, 0, minus 1. So, first combination, this one. So this one, this combination, and this combination, this combination, and this combination, this one, this, sorry, this. So there are 9 possible combinations. There are 9 possible combinations of this plus 1. For example, ms plus 1, ms plus 1, this is plus 1. So 9 possible combinations are. And what is this one? L equal to 1. L equal to 1. Now we apply the term symbol. L equal to 1 is P. L equal to 1 is P state, so P. And S equal to 1. S equal to 1. Therefore 2 into 1 plus 1, 3. Triplet state. P3. P triplet state. P triplet state. Okay. Next, so we have obtained one state. 9. Now still we have 6 more. Choose the maximum ms. Next, choose the maximum ms and ml value. Next ms, maximum ms value. Next maximum ms value 0. Okay, therefore S equal to 0. S equal to 0 and L equal to, see, L equal to plus 2 you have. L equal to plus 2. Ms equal to 0. Choose the next maximum ms value. Okay, minus 1 is next. Okay, 0. So L equal to 2 and the ml value. Therefore, ms equal to 0, ml, there are 5 possible values, plus 2, plus 1, 0, minus 1, minus 2. Therefore, combination, there are 5 combinations. ms 0 plus 2, ms 0 plus 1, there are 5 combinations. Okay, so this one and this one. So there are 5 combinations. As you see, the 5 combinations are minus 2, plus 2, minus 2, plus 1, minus 1. Okay, and you are D1 state. 5 combinations. The 5 combinations are D1. D1. Why it is D1 state? Because L equal to 2 means D and S equal to 0 plus 1. Therefore, D singlet state. D singlet state. Okay. We obtained the 2 states. We obtained the 2 terms, 2 spectroscopic states. Now, remaining one is there. That is, remaining one is remaining ms equal to 0, ms equal to 0, ml equal to 0. That means ms equal to 0 means S equal to 0 and L equal to 0. Therefore, L equal to 0 means S state. Therefore, L equal to 0, S state, and we will find out next class the J value. Okay. Now S and S equal to 0. Therefore, singlet state S1. Singlet state. Okay. So we have obtained there are 3 terms. Among the 3 terms, one is the ground state. We will see what are the rules to obtain the ground state. Which one is ground state? We don't know. We will see in the next class. There are 3 simple rules to obtain the ground state and the excited state, spectroscopic state, excited terms. So there are 3 term symbols for the 15 possible configurations. Microstates P3, D1, S1. In the next class we will further see. So we have applied, we have studied the term symbols. What are term symbols? How it is applied to obtain the spectroscopic terms for P2. Similarly, D2, D3, D5 we can obtain for any configurations. So please understand, this is very important. Based on this, they will ask different types of questions. If you understand the fundamental, you can answer any question. That is my advice to you. Thank you for watching.